get started. Like, please have your seats. We're going to get started in 1 minute.
Ladies and gentlemen, please take your seats. We'll be getting started in 1 minute. Ladies and gentlemen, please join me in welcoming MongoDB Regional Vice President Susan Palmer.
Good morning, Seattle. Thank you so much for joining me today, or joining us today at MongoDB Local Seattle. Today we have the entire Northwest sales team and a slew of technical experts to help you answer questions and learn a little bit more about MongoDB today. We have a tremendous program ahead and a lot of exciting news. But first I want to thank you for taking time out of your week to come spend the day with us. We're looking forward to getting to know you a little bit better and sharing a little bit about MongoDB. We have a couple things I want to remind you. Please feel free to tweet #MDBLocal and download the MDB Local app. We have a contest every time you're going through a session and leave a rating. You'll be entered for a $100 gift card. Not bad. So as I mentioned, we have quite a lineup today. Customer speakers, please use the time to network, learn a little bit more, visit the Ask the Expert booth, which is open all day long. It's a first come, first served, but we'll certainly take time to answer any questions that you have. So, as I mentioned, we have some exciting news today, but don't take my word for it. It is my pleasure to introduce to you MongoDB's CTO and co-founder, Elliot Horowitz.
Thanks, Susan. Good morning, everyone. It's good to be in Seattle. So we've got a really exciting morning and a whole day prepared for you. So I hope you'll stay with us all day, have a really great day. I hope you learn a whole bunch of stuff about what's in MongoDB, how MongoDB can help developers be more productive. You know, it's one of our core tenets is how do we make developers more productive, and about a bunch of new, cool, and interesting stuff that we're working on. So the first thing we're going to talk about today is MongoDB 3.6. So MongoDB 3.6 actually came out in December, and there's chock full of great features, again, focused on making developers really productive, making sure that the data you're working with is the best way, making sure that MongoDB is the best way for you to work with data, and making sure that we've got all the pieces to build a really great system. And a lot of what we're going to talk about is based on the document model, right? We fundamentally believe that the document model is the best way to work with data because it's the most natural way for developers to think about data, the most natural way for programmers to think about data, because it's the way that people think about data. It's the way that other applications think about data with classes and structures and hierarchy. And so a lot of the things we're going to talk about are how we can make the document more effective. So the first feature we'll talk about is $lookup. So in MongoDB 3.2, we added support for $lookup. And something's not quite right. But so in MongoDB 3.2, we added support for $lookup originally. And $lookup is the way you can do joins in MongoDB. So in 3.6, we made a lot of enhancements. So in 3.6, we can do a lot more expressive $lookups. So here's an example schema. Here's a document. It's an order from an e-commerce store. So in this order, we've got line items. So you've got, for each thing you purchased in your order, you've got a line item. So you've got an ID, 123, you're buying a battery, and you've got a price. So let's imagine that you want to display ratings. You want to display one order on a page, and you want to display ratings for each one of these things. So effectively, what you want to do is a join between the orders collection and the reviews collection. So in 3.6, you can do that very simply. You'll do the order, you'll join it with the reviews collection. You can actually do a full subquery in that $lookup. So for each item in the line item, you can actually go through and do a group and do an average. Right? So you can actually compute very easily in one aggregation query the average rating for every product in that order. Right? Just making it really easy to sort of leverage the database to do all this kind of work and to do other analytics. So the next thing we'll talk about is arrays. Right? If you think about what makes a document database so powerful, it really comes down to arrays. Right? Because arrays give you the choice of embedding sort of one-to-many relationships directly in the document, which is a really powerful concept. And we've made a bunch of enhancements around how you can update arrays. Right? So you've always been able to update individual elements in an array or sub-elements in an array, but we've made that even better. So the first thing we're going to do is we're going to look back at our same order. And what we want to do is give this person a 20% discount. So we want to multiply the price of every line item by 20%. So now you can do that with one query in Mongo. You're going to go through, you're going to say update line items.price with this little modifier in there that says update every single line item. What if you only want to update some of them? What if you only want to update items that you haven't yet shipped? Maybe like half the order got shipped, half the order didn't get shipped. So for every level of hierarchy in that array or in that document, you can actually put a predicate. So you can actually have a predicate in here that says update every price of a line item, but only the ones where it has not yet shipped. So now no matter how, and then of course what if you're even more nested, right? What if you've got multiple levels of hierarchy? So in a document like this where I want to update my phone number, you can do that as well. Right? So as many levels of hierarchy as you have in your document, you can update some or all elements, and you can have predicates at any level you want, right? Making it really easy in a single operation to update the document. Right? And this is really powerful because inside of that document, inside of that one update statement, everything is atomic, which just makes it that much easier to work with. So we're calling this feature the fully expressive array updates. It's quite powerful. It's been around for 2 months now, so check it out. So the next thing we're going to talk about is schema. So when we first started talking about MongoDB about 9 years ago, we often called Mongo a schema-less database, which of course actually doesn't make any sense. There's always schema associated with data. There are indexes in Mongo. There are types in Mongo. So of course there are things you can do. And so we tried calling it a flexible schema or dynamic schema, but somehow the schema-less moniker has stuck, even though it's not quite accurate. But for a lot of people, they want to have some level of enforcement of the database. Right? So what you really would like to be able to do is have flexibility as you're developing, as you're adding new features, to modify the schema very quickly, but you want some level of enforcement of the database. Right? Maybe you've got different applications running to the same database. Maybe you're ingesting data streams from lots of different vendors, and you want to make sure that a bug in some downstream vendor doesn't cause data corruption in your application. So in MongoDB 3.6, we added support for JSON schema. And what JSON schema does is let you define a schema for documents in Mongo in JSON using the industry standard JSON schema. Right? We've extended it a little bit to support more types in Mongo. Right? Mongo has more types than JSON does. But it's the same syntax, same format. So here's an example of what it would look like. Basically, you say what the properties are, if they're required, if you're allowed to have more properties, or it has to be very explicit, and you can put types on them, saying it has to have in this case, it has to have a price. Right? Every line item in your order has to have a price. It has to be a number, and it has to be greater than or equal to 0. Right? You're not going to sell things for negative amounts. And then you put this schema on the collection, and every time you do an insert or an update, it makes sure that whatever document you put in there is valid. And the great thing is, this is obviously completely optional, and you can make it as flexible as you want. So if you want to learn more about how to do sort of schema modeling with Mongo, I'd encourage you to check out the advanced schema modeling talk a little later this afternoon. So the next thing we're going to talk about is Retryable Writes. So one of the great features of Mongo for a very long time has been high availability. Right? You have a replica set in MongoDB. When there's a failover, when there's a hardware failure or a network failure, there's an election, a new primary takes over. Right? We can now guarantee that those things happen in less than 1.7 seconds. So it's very high availability. But what happens to writes during that window? Let's say you do a write in your driver. Let's say you're updating a document, and there's a failure. You don't know what happened. You don't know if the hardware failed. You don't know if the network failed. And you don't know if that operation failed, if the network connection failed before or after it got to the server, before it was committed. And so with Retryable Writes, you can say the database and the driver now have a contract that says if there is a network error, for whatever reason, a hardware failure, an election, just a transient network error, retry the operation, and the database will guarantee that will happen once and only once. So how do you do it? Well, it's quite simple. So all you have to do in the 3.6 drivers is turn retry writes equals true on the connection string, and everything else is done for you. So if you turn that on, and you get a write error when you're doing an insert or an update or a delete, the driver will automatically retry that exact same operation. There's a unique ID in the database. If it had seen it before, will not apply it again. And if it hadn't seen it before, will apply it. Right? Making it super easy to write applications with even higher availability and sort of less user pain and less sort of work for the developer. If you want to learn about how we implemented this in 3.6, just listen to the talk. It's quite a good talk. It's given by Shane a little bit later today as well. So the last thing we're going to talk about in MongoDB 3.6 is change streams. Right? Almost every application today wants to be real-time. And with change streams in 3.6, you can do that with Mongo very easily. So what change streams does is give you a feed of all the changes happening inside the database with a really nice API. So if you want to be able to update some downstream data, or update some user code somewhere, or update data sitting on a mobile phone, with change streams, that's very easy. Again, so what does it look like? It's just like this. So basically, if you open a change stream on a collection, you can either get all the changes, you can say, I only want inserts, I only want updates, whatever you want. You can put other filters on it. So maybe I only want to get notified of new orders that happen to be placed in a certain zip code. Right? So it's super easy to sort of say what you want to watch, and then you can just start looping over that. This is the Python code. And whatever language you're using, it's going to be a very idiomatic way. These are restartable and restartable, so you will get a token that you can save and restart from the exact place where you left off, so you can have some really good guarantees about making sure you're doing everything exactly once. And again, if you want to learn how to use it and how it works, check out the talk using change streams by Asya again, I think right after this. So those are some of the really interesting features coming in 3.6. So as I said, 3.6 came out in December. It's obviously in MongoDB Atlas already, so please check it out, upgrade, give us feedback. We'd love to sort of see where you are. So next, we're going to keep working on our e-commerce app. So we're going to use the document model to make our e-commerce app a little bit more powerful and add more features there. So let's imagine that we have our orders collection, which we've been working with, and now let's imagine that we want to also have an inventory collection. So now what we want to do is after we insert an order, for every line item that we purchase, we want to decrement the inventory count, right? So we know how many things we have in real time, so we don't oversell things, so forth, right? So in Mongo, this is quite simple, right? You're going to insert the order into the collection. You're going to iterate the list of line items and do an update for each one. Very simple, very easy. But what happens if there's an error? Right? What happens if before you start iterating that array, or while you're iterating that array, something goes wrong? Maybe your app server crashes. Right? That's bad. So how do you handle this? Well, what you can do today is you can have some background process that goes and updates the inventory, or something that goes along and sort of makes sure that the things are valid, creates some sort of change log. Sounds kind of painful. So what you really want to do is this. Start a transaction, insert your document into the orders, update your line items, update your inventory, and then commit the transaction. And that would be really nice. So this morning, we are announcing that MongoDB is officially dropping ACID. So multi-document, fully ACID transactions coming to MongoDB in MongoDB 4.0 this summer. So what are transactions in MongoDB going to be like? Well, they're going to be completely familiar. As you just saw, they're completely familiar to anyone who's ever used transactions before. Right? You begin a transaction, you commit a transaction, you abort a transaction, just as you'd expect. They are fully conversational. Right? Put your reads in there, put your writes in there. everything that you want to do, just if it needs to be in a transaction, just put it in that transaction. Multi-documents, multi-collection, whatever you need to do there. Within that transaction, you have full snapshot isolation, right? So you can do a read and then do some writes, and then when you do the writes, you make sure that you're guaranteed there's no conflicts there. It meets all of the standard ACID guarantees that everyone can expect. So we have this little ACID seal of approval. And if you're not using transactions, if a write doesn't have a transaction, there's absolutely no performance penalty whatsoever. If you want to use a transaction for one tiny little operation and nothing else, you will see like no performance impact. If you want to use it for just one thing, all you have to do is use it for that one operation and then nothing else. That's it. Super easy to use. So when would you use transactions in Mongo? Obviously, there are applications in Mongo, mission-critical applications across almost every vertical not using transactions. So we expect that many users of MongoDB are going to use transactions in very small ways. Right, so you may be doing 100 different operations on the database, and maybe one of those transactions is going to make really much easier. So for example, the e-commerce example I gave before, I think that's a really good example. The other example that comes up a lot in meetings that I have is, let's imagine you've got a very large data set in Mongo, like a 100 terabyte data set, and you're inserting to that data set all the time, and you want to have a view of that data, some aggregate view of that data that's updated as well in real time, so you can do analysis on it very quickly. Well, with transactions, you can have one transaction that inserts a document into that very big, 100 terabyte collection and updates this the roll-up view at the same time, making it super easy to do that. So obviously, we didn't wake up yesterday morning and decide, oh, it'd be really cool if we announced transactions in Seattle tomorrow. So we've been working on transactions for a long time, right? So it all started when we acquired WireTiger about 3.5 years ago, and then we've been working on it ever since. And so in MongoDB 4.0, right, which is this summer, we'll have replica set transactions. And in MongoDB 4.2, which is our next release, we'll have fully distributed sharded transactions across, as widely distributed a cluster as you can have in Mongo. You might say, well, there's still a lot of, going from replica set transactions to sharded transactions, is that a lot of work? Well, there's a big difference, but most of that work's already been done. So, for example, I mentioned two features in 3.6, change streams and retryable writes. Great features that are going to make developers more productive, but at the heart of both of those features really is the building blocks for sharded transactions. But if you look at the list of things in 3.6, you'll see causal consistency in there, you'll see sessions in there, core building blocks of retryable writes, and change streams. So there's more work to do, but it's really the last little bit that we've got to finish. This is the first major announcement that we've made since going public in the fall. So our lawyers have said we have to put this on the screen for a few seconds. You'll also find the same statement on every blog post we're going to release today and many other blog posts that we'll have, so get used to it. So what do we want today? So as we're finishing up transactions for 4.0, we really want to get as many use cases as possible to make sure we're covering all of our bases, to make sure we can deliver the best possible transaction experience in 4.0. So we have launched the beta program, mongodb.com/transactions. If you've got a use case for transactions, please join the beta program. Let us know. We're going to be trying to get a really great set of transactions. We've got a bunch of good use cases in mind already, but we really want to find as many of them that are out there as possible. So please let us know if there's anything else out there. Obviously, we're quite excited about transactions. It's been, people have been asking me about transactions for as long as MongoDB has been around, and this is sort of the culmination of many years of work. So we're super excited about them. I hope everyone is excited about them as I am. So we're going to move on and continue talking about the next sort of new things in Mongo. So the next thing we're going to talk about is business intelligence. So business intelligence is sort of, in our way, is how you can get data out of MongoDB and analyze it as fast as possible. So the first thing we announced, released a couple of years ago, was the BI connector. Right? And the BI connector lets you query data that's sitting in MongoDB from tools that speak SQL. So if you're using a tool like Tableau or MicroStrategy that speaks standard SQL, you can do queries live out of data sitting in MongoDB using SQL, and the BI connector will translate that SQL into Mongo aggregation queries and run them. So these are a bunch of charts, for example, that are built out of, that we use internally, that are built out of data sitting in MongoDB using the BI connector. So the BI connector version 2 came out in December. Lots of improvements. If you think about the main purpose of the BI connector, it's to push as many things down into MongoDB queries as possible. But if MongoDB doesn't support something, it has to do it itself. But its job is to take SQL and spit out the best possible MongoDB aggregation query it can. And when it's showing you documents as a relational view, figure out the right way to do that. So lots of improvements in the new version of the BI connector around performance and ease of use and management. And one of the questions is sort of, why is this hard? What's interesting about this? Well, the first thing is that documents in Mongo aren't flat, right? SQL isn't meant to do this. And so one reason why it's hard is that most documents in Mongo are polymorphic in some way. So again, looking at our e-commerce store, this is our product catalog. So we've got two different documents. One is a t-shirt, one is a battery, and they've got different attributes, right? And you need a tool that can understand this. The next thing is arrays. And so in arrays, there are two different ways you might want to look at it. There we go. And so this is, again, our order document. So two ways you might want to look at it. The first way you might want to look at it is find the most popular items. So looking at each line item independently. The next way you want to look at a document is looking at a histogram of order price. So first, now you want to do some analysis on each document first to compute the total order price, and then analyze the whole thing. Right, so two ways of sort of fundamentally looking at arrays differently in Mongo. So I said before that these charts were built with data sitting on MongoDB. That's true. I implied they were built with the BI connector. That's not quite true. They were actually built with a new product called MongoDB Charts. And MongoDB Charts is a tool that lets you build native dashboards and charts right on data sitting in MongoDB that understands polymorphism, understands arrays, and automatically spits out MongoDB aggregation queries. So that's how you can build a chart. This is how you can build a dashboard. And because it is such a great visual tool, I'd like to invite Grigory Melnik, our head of product for server and tools, to the stage to give you a demo.
Thank you, Elliot. Hello, Seattle. I'm super excited to be demoing MongoDB charts to you. You can see I'm excited about transactions too. Next time. So MongoDB charts. Whether you are a business analyst who wants to get some insights from your data, or you're a developer who just wants to put some quick visualizations on top of the data and share them, MongoDB charts is for you. So let's jump right into the demo. The first part is going to use the data set called Stack Overkill. Some of you may be familiar with it. It's basically ranking the popularity of different libraries, frameworks, databases on Stack Overkill. You can see that I've got the MongoDB charts here loaded, and I'm already connected to this database and have the collection open. MongoDB charts automatically recognizes the schema and gives me the fields. And all I need to do is really just drop the fields into my axis to get a chart going. Just that easy. You see, I was able to build the chart before even finishing the sentence. I can make it a little bit more interesting. Actually, let's do this by color. And there you have it. So a very nice, very easy to build, very intuitive charts in a matter of just a couple of clicks. Now, the important thing here to highlight is that as I was building this, it didn't involve any kind of data transfer, funneling it anywhere, data wrangling, ETLing to, I don't know, Elastic, using Kibana, knowing anything about D3 or other type of visualization libraries. All you have is just a tool that lets you do this extremely quickly and then share it in the form of reports or dashboards or what have you. Wasn't it cool? Easy enough? Shall we do it again? Let's do it again. Of course, I can reset this chart, but I'm actually going to use a different data set, something that's a little bit more interesting. So this time, I'm going to look at the anonymous telemetry data coming from Compass. Compass is the tool, an intuitive tool that many of you are using today, a GUI tool on top of MongoDB, basically. Again, it allows you to do data exploration, some basic operations, just a great tool. And if you choose to send us the telemetry data so we can improve the product, this is the data that we actually get. So now, just like any clickstream data, this data is polymorphic in nature, so I'm actually going to look for the event type schema sample because I want to analyze the types of schemas, the types of documents that you guys are working on. So I'm going to look at the schema depth. So let me just grab the schema depth field and drop it here. I'm also going to grab the ID just to get the count. And just that easy. Actually, let's change this to an ordinal type. I can see immediately that most of the schemas that people deal with are flat, right? They're just depth 1. There's some that are a little deeper, and then there's some that, in my data set, show the depths of 5, and that's actually pretty sophisticated, pretty complicated. Think of the nestedness of like A.B.C.D.E. Now, what about schema width? Width is the maximum number of fields that any of your documents in a given collections have. Also something interesting to look at. So let's just drop that one in. I'm just going to replace it like that, and you can see that the histogram has been built immediately. I can get the insight that most of the documents are between 10 and 20 fields wide, and there's some that are kind of outliers here, getting closer to 200. Well, again, I'm not totally surprised. I've seen some with thousands, though I'm not sure I would recommend that. But anyhow, now what about actually doing the multi-dimensional visualization? Can I actually compare width against depth? Well, I think I can. So why don't we actually use the scatter plot for that? And again, you can see that there's just a few here that are shipping in the box. Of course, by the time we launch it as a GA, you're going to see a much, much, much richer set of the built-in visualizations, and will enable extensibility layer for you to plug in your own types if you want to. But I'm going to use a scatter plot for now. So where's my schema depths? I'm actually going to drop the count over here. Where's my schema widths? Right? No, that was widths already. So let me just get the depth. And there we go. Actually, I'm going to swap these two axes because I think this looks better this way. Just zoom it a little bit. So now you can see that I've got a scatter plot with the very clear cluster where most of the schemas tend to be. Great. Now, what about users and the type of user machines that you guys are using when again, running Compass at least? So I'm going to get another data set here, and I'm going to filter it by the city of New York, where the headquarters of MongoDB are. So the first thing I'm going to look at is how about the cores, the CPU cores? Now, why is this important to me? Well, as a product manager, I want to know the type of machines that you're running my tools on, right? Because then I can know, can I take advantage of multi-core architectures, right? How much of buffering can I do? So cores and CPUs and a whole bunch of other information is truly useful. So again, let's just do it this way. I think the bar chart would be best. I'm just going to get the count. And all right. And let's actually, why don't we reset this? I might have screwed up. So bar chart. And the host cores. Okay, let's get the count. And for some reason, oh, I see. And the count. Well, actually, never mind. This is I can ignore this piece. That's okay. We have another cool part of this demo. Actually, the final part, I think, is the most exciting. So it's actually going to highlight the power of MongoDB when it comes to manipulating arrays. So as we're sending some data, we're actually collecting the segmentation data. So I have a segment field here. Now watch carefully what's going to happen once I drop it in here. Did you see that? MongoDB automatically, let me just zoom on it a little bit. MongoDB charts automatically recognize that that field is of a type array, and now it offers me a number of different ways of how I can handle it, right? So I can go and unwind it, I can grab the length, I can go and apply some of the statistical aggregate functions, which is again awesome. I'm actually going to do that. So I'm going to unwind this, and great, grab my ID one more time, count, and I'm going to do the bar plot right here. And what you can see is that the information about some segments, actually let me just clean this filter out. There we go. I can see all segments information here. This is actually better. As a histogram, right? Now, the piece of information I'm specifically looking for is actually how many people are using Windows versus OS X. And you can see it's right here and here, but there's also some other part, because remember, I just flattened the array, right? So this feels like a little bit of noise that I don't need on my visualizations, because all I want to see is the clear representation of the operating system distribution. So I'm just wondering, is there a way for me to filter it out further? And you've probably seen it because I already applied that filter. I'm actually going to use the power of the aggregation framework that allows me to actually filter it and do a projection further on the data set and the presence of the specific fields, specific values, as you can see here. So once I actually apply this, you can see that now my chart is clean and exactly what I want it to be. Now, just to prove it that I'm not using some kind of a canned static demo, I'm going to actually change this to another city. How about the city of Redmond, just over the lake, right? Any Microsoft people here? Are you worried? Right. Well, don't worry. It seems to be like... sorry, I can make the joke. I'm a former Microsoftie, so it's all fair game. So anyhow, Windows seems to be, winning there. Now, what about the city of Seattle? Let's take a look at this one. Ta-da! Voila! It looks like in Seattle, at least the battle of operating systems is over, and the same popularity. So that's great. Now, again, just to highlight, I was able to build all these charts in just a few minutes with different types, scatter plot, heat maps, bar charts, what have you, directly against the MongoDB data without any need for data wrangling or, again, ETLing it anywhere else. So on that note, I'm happy to give you MongoDB charts with with more peace, love, and rock and roll, and invite Elliot back to the stage. Thank you very much.
Thanks, Grigori. So that's charts. So the beta for charts is going to be launching very shortly. So if you're interested, please let us know. We get a lot of eyes on it. Make sure it's looking pretty good. So the next thing we're going to talk about this morning is MongoDB Atlas, right? And so MongoDB Atlas is our database as a service for MongoDB, right? So why do we have Atlas? What is Atlas? Well, Atlas, we believe, is the most reliable way to run MongoDB in the cloud, the most secure way to run MongoDB, the easiest way to run MongoDB, and the most elastic and most flexible way to run MongoDB. So we launched Atlas about 18 months ago as a database as a service, and we've added a lot of features since then. So about a year ago, we added a free tier. So everyone who wants just a free MongoDB cluster in the cloud, you can just go and get a free tier. A live migration service. So you can actually live migrate existing replica sets and very soon sharded clusters right into Atlas very easily with a very little downtime. A data browser, so you can actually see the data in your cluster right in the Atlas UI. Real-time performance viewer, so you can see what's happening in real time, what collections are hot, what kind of queries you're doing, things like that. A performance advisor will actually go and tell you what indexes you might need to add to make sure your database is running smoothly. A cheaper tier, so now we've got the free tier, which is obviously free. We've got an M2 tier, which is $10 a month, an M5 tier, which is $25 a month, and an M10 tier, which is $60 a month. So wherever you sort of fall into the spectrum, you've got the right thing that you might want. And the BI connector is now built into Atlas. So if you want to turn the BI connector on in Atlas, you click one button, and then you can start running SQL queries against MongoDB in the cloud. And one of my favorite features is queryable backups. Right? It's very simple to have backups, but let's say you've got a big data set, you've got a terabyte data set. Most often, if you want to look at a backup, you don't want the whole thing. Right? You want like one document. Right? Now, if you have to restore 1 terabyte data set to view one document, it's kind of a pain in the neck. So with queryable backups, you can actually query the data live while it's sitting in the backup format. So you can actually do a query sitting on the backup in a matter of like 2 minutes. Right? So you turn on it, you say, I want a queryable backup on a certain snapshot, and then within, probably even faster, actually do a query against that snapshot, load your document, shut it down, and you're done. No restoring 1 terabyte of data to look at one document. And the ability to pause clusters. So if you have a cluster that you're only using for development, every night when you go home, you can pause it so you don't get charged for it while you're sleeping. So Atlas is also available across all 3 major public clouds. which is pretty exciting. So that no matter what public cloud you're on, you can do this. We have cross-region replication. So if you want to have like a couple of primary regions and then backup regions, or you want to have secondary reads in lots of locations, so you can have your main data set, your main sort of locations on the West Coast, but you want to have a secondary for your data sitting in every single Amazon region. So you're using US West 1, US West 2 as your primary Atlas regions, and then US East 1, Europe, Australia, Brazil as your secondary read regions, so you can do local reads no matter where you are. All that stuff's available today. And to show you just how easy it is to do, I'd like to invite Muthu Chinnasamy, a solution architect in Seattle, to give you a demo.
All right, thank you, Elliot. Good morning. Glad to be here and show you what we've been working at MongoDB Atlas. So MongoDB Atlas is a fully managed database as a service for MongoDB. It has all the security and operational best practices fully built in. We keep these systems secure, healthy, and patched. What you are responsible for is provision a cluster on Atlas and build an application on top of it. So to get started with, let's get started with build a new cluster. The first thing you do here, so all the deployment capabilities that Atlas makes possible are available in this form. So you can also implement these activities through declarative RESTful API calls. So you choose the version of MongoDB. So the beauty with MongoDB Atlas is any new release of MongoDB, the same day we make it GA, is also available on Atlas for you to experiment right away. Then you choose the cloud provider you are going with, and then the region where you are deploying. So we have more than 43 regions around the world, and that number is going up. Then you see, lastly, you select the instance type you are going with, ranging from M0 all the way to a very powerful M200. So here, Elliot mentioned about M0, the free tier. That's what's available here. We see it as a development sandbox, an alternative to a laptop on the cloud for your side projects and new ideas. So you should come and give it a shot. So then you just confirm and deploy, and your cluster will be ready in the region you selected. So Elliot also mentioned about cross-regional clusters. What are they and why would you need them? So to illustrate that, let's go and enable cross-regional replication and then deploy across multiple regions. So there is this preferred region. So I'm going to choose Oregon. So meaning whenever this region is up and available to me, that's where the primary will be, and that's where your writes go to. And let me add a few regions. In Virginia, let me add 2 nodes. And let me choose one more region. Let's choose California. And I'm going to add 2 more nodes. So in this setup, if for whatever reasons the Oregon region is unavailable, I still maintain quorum with Virginia and California providing me 2 + 2, 4 out of 7 majority quorum. I have my reads and writes throughout. So with this high availability taken care with a cross-regional cluster, let me add a cool feature in Atlas. Click on the read-only replicas, add read-only regions far away places like Sydney, Australia, and also a few more. You can add any remote region. So very quickly we added 2 regions in faraway places where the users over there can do proximity querying, low latency, right in their region close by. So scrolling down below, you also have your scaling questions. If you want to scale MongoDB cluster, you can choose sharded clusters and go up to 12 shards. Backups are enabled by default unless you don't want. And then this is the feature that Elliot talked about, BI connector. Your SQL tools can be hooked up to MongoDB Atlas right here, and you can fire SQL queries and get your results directly from MongoDB. And lastly, you hover your mouse over the hourly cost, and that tells you precisely what your monthly costs are, and then you're ready to click confirm and deploy. So moving a few minutes to the future, this is how your global cluster will look like. So at this point, you're ready to set up your security, role-based access control, IP whitelisting, and better yet, if you have your application servers on EC2 instances, you can establish VPC to VPC for private and secure connection. So with that built, one of the things that we advocate as a DevOps practice is expect things to fail, chaos engineering. Right? So we have a feature for that. We call it the chaos button. So test failover. So when you do that, Atlas steps down or takes down your primary and lets an election process to happen. So this way, you are able to test failover scenarios, regional failures during your development process and get ready to go to production with confidence, no guesswork involved there. So we have deployed a cluster, tested resiliency, you are comfortable, you have pre-existing clusters out there, and you are wondering how do I bring that to MongoDB. So we have a migrate data to this cluster feature. So when you are ready, you just provide your host port and credentials, SSL, yes or no. And then when you pass, Atlas will do an initial sync by pulling data from your source cluster, and it will keep up with the changes that occur throughout. And you hover your mouse to this clock, it will tell you how much time remaining to complete the sync period. When you are ready, you see that clock showing close to 0. That's when you are ready to cut over. So when you hit on the start cut over, you are ready to stop your application servers, update the connection string, point them to the cluster that we just built on Atlas, and then restart your application server. And voila, with a just bounce off your application server, you achieved a transfer to Atlas. Very powerful feature. So your data is in there, and we also have powerful features in here to explore your data by going to the data. And you can see, you can explore your JSON namespaces. You can also write your queries right in here. We have powerful alerting capabilities that are enabled by default with a good choice of built-in, so you don't have to worry about them. But you can extend them by building additional alerts by sending alerts to your Slack or PagerDuty or email on a variety of metrics based on thresholds. And then you also have hundreds of metrics on MongoDB metrics, replica metrics, and also operating system metrics. These are available on various granularities, various zoom windows for you to experiment and see in action how your cluster is doing versus your workload, and also do trend analysis for capacity planning. But if you're asked what's happening in my cluster right now, this second, the real-time performance panel is the one that Elliot talked about. So when you go here, we have some select metrics available, like memory, the network transfer rates, the CRUD metrics, and then you see on the right side hot collections in my cluster. And at the bottom, you see slow queries that are going on my cluster also. So you can explore and see what's happening in low-level operations. But if it's impacting your production right now, you can kill up by choosing that button right there. But this is taking care of the issue right now, but you want to solve the root cause. What's causing that slowdown? So the real-time, from there we move on to the performance advisor. This is a feature that we built that analyzes your workload in real time, sees an opportunity to add an index to improve that query, and makes it available for you. So you can come here and consume it, go to the more info, it precisely tells you what needs to be copied and pasted into a Mongo shell to create that index. So the performance advisor is an opportunity that we enable for you to get the best bang for your cluster's buck here. So let's say you implemented all those improvements, but still you're not getting the SLA metrics. It's time to scale your cluster. So we go to the same place where we started, get the same experience. So here you see I'm running on a M10 cluster. I can go to a M20 in the development cluster section, or I can go to a M30 on the production cluster section. And you see with a simple click, I'm able to scale and just go confirm and deploy. This will be implemented with a rolling best practices manner, one secondary at a time, and finally we do the primary. So let's talk about another DevOps practice. So you are constantly working on next week's push code versus last week's production data. And this is a repeated cycle. You want it regularly for your new code, new code. So with Atlas, we take continuous backups and the ability to do point-in-time restores. So the same feature you could leverage And what we built is basically you pick a snapshot and then choose a cluster to restore to. So this way, I can restore to a completely different project that could be in non-prod and for my testing purposes. So very powerful. And you also have this queryable backup feature here. So a lot of times you don't restore your terabyte size cluster, but most often someone thought they were in non-prod, but actually they were in prod. They messed up with some data. They're asking for your help. Or application corrupted some data. So whatever reason, you want just 100 or 1,000 or 2,000 small set of JSON documents, you query against your backup directly and get the data real quickly into your cluster. And then you may also be wondering, my cluster is not 24/7 in my non-prod or lower environments. Is there a way to optimize? So we have that available also. This is the paused cluster that Elliot mentioned. You can see the active cost is 9 cents an hour. In the paused state, the cluster is only 2 cents an hour. So whenever you're ready, you can come back and resume your cluster. So with all this rich functionality available in Atlas and more coming, our pipeline's ever strong, what are you waiting for? Build a cluster, come and talk to us. With that, I pass it back to Elliot.
Thanks, Muthu. So obviously, we're very excited about where Atlas is today, but of course we're not done. There's a lot more things we're working on. Some of my favorites are full CRUD support in the data browser. So the same data browser that Muthu just showed you, we will add support for doing updates and inserts and deletes and adding indexes, sort of the full CRUD experience right in the Atlas UI. Support for MongoDB charts, no-brainer, right? You get this great charts product that Grigori showed you. We'll be able to put that right in the Atlas UI, so you can start building charts very easily. The ability to do full database auditing for databases hosted in Atlas. So if you need to be able to audit certain types of operations or every database insert, for example, you can do that. Integration with LDAP. So if you've got some other LDAP service that you want users to be able to log into the databases with, be able to work with whatever LDAP service you have. KMIP, or actually probably more like KMS integration, so you can use your own encryption keys for data that's in Atlas. So if you don't want us to have access to the data anymore, you just delete our access to the keys and we're done. And one of my favorite features, cross-cloud clusters. Right, so the same way you can have cross-region clusters today, the ability to have cross-cloud clusters. So if you want to have some data that stays in Amazon, or some data that stays in Google, or a copy of the data in Google because you like their AI algorithms better than Amazon's, and you want to be able to do machine learning on that data that's sitting inside of Google, you can all do that very easily. Or maybe you just want to be able to switch clouds, all super easy to do. So that's MongoDB Atlas. If you haven't tried it, please do. Give us feedback. Take a look. So we have one more thing to talk about this morning, and that's MongoDB Stitch. So MongoDB Stitch is a backend as a service for MongoDB. So actually, we started off building MongoDB as part of a platform as a service almost 11 years ago. But a lot has changed in the last 10, 11 years in terms of development practices. So for example, the web is now a first-class UI. So the last time I really tried to build a web UI was about 2006. And we were playing with JavaScript and doing a little bit of that kind of stuff, but it was super early. And now most web applications that are being built are web applications, not sort of HTML applications. Mobile, right? 2007, the year that we started working on MongoDB, was the year that the iPhone launched. Right? So now, if an application isn't mobile first, it's got at least a mobile application as well, and that's really important. I mean, the other IoT has sort of exploded in the last decade for lots of reasons, and services is the other big one. Right? So 10 years ago, if you wanted to do things yourself, you would tend to install some package, write some scripts, and put this together. Again, in 2006, I had to build an image scaling service. So we were handling millions of images a day. For each image, we needed to create a bunch of different thumbnails. So what did we do? We downloaded ImageMagick. Take a step back. First, we actually purchased two Linux servers, put them in a rack, powered them, installed ImageMagick on them, wrote a bunch of Python scripts, and put this whole thing together. Now you would never do that. Right now, you would go and use one of the numerous services out there for doing image scaling or image storage. And now there are services for basically everything you want to do, whether it's sending text messages, sending emails, talking to Slack, billing credit cards. There's basically a service for everything. And so what does a modern app really need? Well, a modern app really needs a way to do CRUD, right? A way to interact with your data. That's really important. It needs to do that very securely, have very good access control, logic, validation to make sure that you can only see your data, to make sure there's no injection leaks, to make sure you can't leak someone else's data that they need about through some sort of weird API call that someone forgot about. And it needs the way to stitch services together. So what's a typical way people do that today? Well, one is they're going to write a bunch of custom code that for every time they need to access data in an application, go and make an API call for that. Lots of boilerplate around security and privacy and validation, and a lot of do-it-yourself security, right? Making who can see what, who can access what, making sure that I don't let someone see something they can't. So a lot of people are working on sort of, there's a whole myriad of space, mobile backend as a service, platform as a service, serverless, and they all have interesting things about them, but they all sort of suffer from similar kinds of problems. One is a lot of them lock up your data. Right? And one of the things we care about a lot is if your data, you should be able to access it in any way you want. You should be able to use a tool like Tableau to access your data, or a shell, or maybe you don't like the service anymore. Maybe you're using some backend as a service, and you're like, what? I don't want to use the backend as a service anymore. I want to write a regular Node app. You want to be able to mix and match and change things. Maybe you want to integrate with services that this thing doesn't support. Right? Maybe you want to just work with your own microservices. How do you make that work in this sort of a platform? And you just tend to be very locked in to where you can deploy it, who's running it, what kind of clouds you're running on. And so Stitch is different. So at its heart, Stitch is a REST API for MongoDB. Right? It lets you run regular Mongo queries from a browser or from your phone. And the reason why that works is because it's got a configuration-based authentication, privacy, and security system. So what you can do is you can set a bunch of rules that says, hey, if someone's logging in and they're, for this document, or it's document field level security, if for this document their role is patient, they can do certain things. They can read these fields, they can edit these fields, they can view these documents. And then you configure this once for your collection, for your roles, for your fields, and then any query you want to do, any aggregation, any roll-up, any update can just run regular Mongo queries, and Stitch will make sure that it doesn't violate any of these rules you have. So they become very easy to audit, very easy to understand, and you can't bypass them. And you can compose other services. So if you want to have a single API called a Stitch that goes and inserts something into MongoDB, then goes and puts it on Amazon SQS, then goes and sends a text message through Twilio, you can all do that with a single API call to Stitch from a web application, from a mobile application, or from an IoT application. And it's anywhere you want. So any cloud you want, you can run it on. You'll be able to run it on-prem. So no matter, on your laptop, so no matter where you want to be able to run Stitch, you'll be able to run it there. So the way a typical application might look is like this, right? So you've got your regular MongoDB Atlas cluster. You can talk to it via a BI tool directly. So if you want to use Tableau or MongoDB charts, you can just talk to it directly, just like you would today. You can access the data via the shell or any other driver that you want, just like you would today. You have the Stitch layer in front of it, and your sort of web clients, your mobile clients talk to the database through Stitch, and Stitch on behalf of your web clients can go and reach out to things like Twilio or S3. So to show you just how easy it is to build an application using Stitch and to start using it, I will do a demo. And because I'm so excited about Stitch, I'm going to do this on myself. And because I am not as tall as Grigori, I am going to take this box away. Great, so let's get started. So here we have a blog post. You can see my very fancy blog. And what I would like to do is add commenting to my blog post. So what am I going to do? So first I'm going to go to MongoDB Atlas, and you can see I've got a Stitch application over here. If I want to create a new one, I would just create one, but I've already got it. And so here we are. Here is our Stitch application. So great. So let's go and build our little application. So first, we're going in to write the HTML that we need. So we're just going to put a block in here to add where our comments are going to live. And then we'll put a box where we can actually insert our new comment. All right. So now we need to go and write the actual code for this. So what we're going to do is copy this boilerplate from Stitch right over here. I'll put this in here. So you can see we're loading the Stitch library. We're going to connect to this Stitch application. We're going to use the blog database. We're going to make DB a global because it's just easy. So we're going to log in anonymously right now. So I've turned on anonymous authentication in Stitch. You can actually use many different ways to authenticate with Stitch, whether it's Google or Facebook. We'll support sort of any sort of OAuth-like system. After we log in, we are going to do two things. The first thing we're going to do is display comments, which doesn't exist yet, but we'll write that function next. And then we're going to save our user ID, which you'll understand why in a few moments. And we'll just get this from the Stitch client. Let's make sure we close everything. Great. Okay, so now let's go and write the display comments function. So this is where it gets interesting. So we're going to take our database, we're going to get the collection comments, and we're going to find this. Now the cool part is here is this is a regular Mongo query. So I can put anything I want here, and Stitch will make sure that I can access that data. If I can't even query on that field, maybe I'm not allowed to know what the predicate is. It will remove that from my query, so I can't do it. But for now, I'm just going to look at everything in the database. I'm going to execute that. After I do that, I'm going to display my comments. So we're going to do this. We're going to write some very fancy JavaScript. I've been trying to learn React. It's not going well. People tell me. Okay, now we're going to take this, take our comments section from below, and just shove this in there. Great. Okay, last thing we need to write is the add comment function. So we'll take the thing we have below, comment, and we're going to insert it. Again, just like we would in regular MongoDB, using a regular MongoDB driver. Comment is, and now everything you insert into this collection has to have an owner ID to get through the security rules, and so that'll be our user ID from above. And after that's done, we're going to redisplay our comments. So it's in real time, and we'll set this blank to 0 or to blank, so that works. Now hopefully, if I did this right, it will work. Hello. Yes, it's working. Great, so now we've got our commenting app. So Indy can, of course, come back here. We can come back here, and we can go and look at the data in the data browser and see what it looks like. And here it is. Give it a couple seconds. And there it is. So that's pretty cool. Now I said before that one of the other things I love about Stitch is the service integration. So before this, I set up integration with Twilio. So you'll see my Twilio integration over here. I'll make this a little bigger so you can see it. So I've got a webhook over here. Oh, that didn't work well. So what this webhook does is it connects, it gets the Mongo service, it gets the arguments from Twilio, and inserts it into the database. So what does this mean we can do? Well, this means that you can send a text message right now if you want to this phone number. It will then turn that into a Twilio. That will go to Twilio. Twilio will set a webhook to Stitch, and then it will show up on our little blog. We'll give everyone a few more seconds. And seeing a few people type. And there we go. It's like SEO spam. That's pretty entertaining. So that's Stitch. In about 4 minutes, we're able to add a comment to the blog. Obviously, you can continue to add features to it and continue on your way. Clever. Anyway. If you want to learn more about Stitch and how to build applications, Drew, one of the product managers on Stitch, is going to be giving 2 different talks on Stitch today. Please check him out. The first one is right after this talk in this room. MongoDB Stitch is available in beta today on Atlas. We've actually got people using it in production already, so if you're interested, go check it out, play with it, give us feedback. GA will be coming soon, as well as multiple clouds and on-premises version. So that's what we've got this morning. We're super excited about everything, super excited about what came out in 3.6, super excited about transactions coming this summer. If you haven't tried Atlas, please check it out, Charts, Stitch. Have a great morning. I'll be around all day. Please come find me. Tell us what you think. And thanks for coming to MongoDB Seattle.
Thank you so much, Elliot. That was really impressive. How many times do you see a CTO come up live coding on stage, right? Well done. So, as Elliot said, thank you all for joining us today, and thank you to our speakers, Mutu and Grigori. They will also be available today to answer questions, as will the Ask the Experts that I mentioned earlier out in the foyer. It is first come, first served, but if we don't get to your question, we'll make sure to follow up with you directly. Thank you also, again, for spending your day with us. I know you're taking time out from the office, from your day jobs. Hopefully now you can go back and tell your boss, thanks for letting me go. I got to go watch Elliot at MongoDB drop ACID transactions. But that's really big news. So we're excited to be able to bring that to you. This is the first time we're making that announcement, and Seattle is where we chose to deliver that message. 2 more things. Remember to download the mobile app. Every time you rate a session, you will be entered for a $100 gift card drawing. This next sessions begin at 10 after 10. They will be in this room, as well as the Sound and Harbor room on this floor. And then we begin lunch at 11:40 downstairs in the International room. So thank you again for coming. We really appreciate it.